Okay, cool. So let's move on to series then. So in this series part, there's going to be a lot of things that we're going to do here. So now this is a building blocks. This is just a single dimension array or list, right? But first we should be able to convert it into a Panda series, right? So that's what we're going to do right now. I'm just going to run through certain things. Creating a series. So what I've done here is I've basically taken different forms of lists, right? So I have certain labels, that is column names. Just imagine this as a column name, and then I have a list of values, just like one row within it, and then I also have an array, NumPy array, and then I have a dictionary also, right? So all of these things are fairly different things, right? So this is a list. Again a list. This is an array from NumPy. This is a dictionary, right? So you have different elements available from the outside world, and now we're going to basically take all these things and convert it into the pandas world, right? So basically what you can do is you can take a panda dot series, right? So that's how you access it, and then you say data is equal to my list. So you basically give this my list, and then you're able to basically create a panda series, and the panda series is, you'll see that it also automatically by default has a index, right? So you have 10, 20, and 30, right? Now pd.series data is equal to my list, and then index is equal to labels, right? So basically I can rename the indexes that you have here, right? So imagine, right, the one that we had exported here. So imagine this is the index, right? And if I want to change this index to something like, let's say, city names, I can basically say Hyderabad, Bangalore, Mumbai, Chennai, right? So all of these things can be renamed, right? So that index can be renamed within pandas, right? So, and that's going to be a crucial factor for us to manipulate a lot of things within pandas. So that's the thing, right? So with a list of values, we can convert it into series, but that series can then have an index of the user's choice, right? So that's a big differentiator in all of the list and arrays and all that we have. Um, and it's very similar to what we have within dictionaries, right? But a big differentiator in terms of what can we do with it, right? So similarly, I can convert, say, pd.series and say my list comma labels, and just get rid of this data and index here, right? So that's how we can look at it. And then NumPy arrays. So basically, if you want to convert NumPy arrays, I just say pd.series and it gives the NumPy arrays. pd.series gives arrays and labels, and then you're able to basically convert it into a series, right? With dictionary, it's very simple because all of the components are there within it. So you just say series and give the dictionary, and then you're just basically going to get this particular series here, right? What we're going to do here is that this is just an example, and you might come across certain examples, right? So within series, we can also store functions, right? So we can store functions. Now this becomes really important when you want to implement some dynamic calculations based on certain criteria, right? So things like if certain criteria is done, then do a sum, or do a average, or whatever it is, right? So Panda series can store built-in functions, which is again a great ways to use in multiple ways. But again, there are different other ways to do it. Hence, this is something that we are not going to directly use it, right? So that's one of the things. Okay, now let's get into some indexing part of it. Right now, obviously, now what we saw was like the basic elements of how we can create indexes from labels and all that. But again, with indexes itself, there are certain things that we can do, right? So in this particular example, what can we do with this index is what we're looking for, right? So for example, here I have two different series with me, right? So I basically get a series with data 1, 2, 3, 4, and then the index we have is country names. Right? So series one has basically USA, Germany, USSR, Japan, and now this is where the beauty of Python will come in, right? And doing something like this within Excel would take a lot here, but within Python, it's just going to be very simple to do it, right? So you basically have another series 1, 2, 5, 4, and then you have USA, Germany, Italy, and Japan, right? So notice you have different names, right? So Italy is one name that you have here, USR is a different name you have, right? Two different names. Now imagine, again, accessing remains the same here, right? I can access it by the index, right? It is same as you accessing it with 0 within it, right? But in the previous cases, but now since we have different types of index, we basically can access in the same way that we used to do it with numpy arrays also, right? That particular logic remains the same. However, the difference comes, and the quickness comes with it, is that when you add these two series, it's automatically going to identify Germany if they are same, and then it's going to add the values within it, right? So that's how you get 4. And you see Italy is a new element here in the series 2. So it's going to basically say NaN because it doesn't really have equivalent element within that particular thing, right? So you have Japan, USA, if they're also available, so hence they got added, but USSR is not present within this, so it's going to be not available there, right? So basically what it does, it simply adds up, and then wherever the value is not present in either of the places, it sort of gets you an N there, right? So again, a great feat within Python, and then again, as we know, multiple steps within Excel had to be done to get to this particular step, right? So that's the series